Hey, welcome back to Rithmetic with Ron. Today we're going to talk about something really helpful, percentages. How do we solve problems that say things like, what percent of 3 is 2? Problems like that. I'm going to show you today how to break that down into something simple that you can use anytime. Hope you enjoyed today's video, and thanks for watching. Let's begin with understanding, with a picture, what are we really trying to do with this kind of problem? Well, what I'm going to do is draw a pie or a pizza, and I'm going to cut it into a piece, okay? This whole thing, the whole pizza, the whole pie, we're going to call the base. This is the whole thing. And now what I'm going to do is write 15% inside of here, okay? This is the percentage, and it's got the little percent symbol. And what we want to know is if the whole base is 300, that's this number up here. If the whole thing is 300 and I cut out a sliver and I say that that sliver is 15%, then what's the number value of that sliver? Okay, that's going to be called the amount. Okay, it's not 15%, that's the percentage, but the actual number. Is it 10? Is it 45? Is it 100? How much does this piece of pie represent in terms of numbers? To solve this, what we're going to set up is a relationship. To solve percentage problems, we have a base, and we're going to multiply that by a percentage, and what that's going to do is give us the amount that we are looking for. Base times a percentage equals the amount. So let's take this question here, which is in English, and we're going to convert it into the math relationship. English to math, okay? So the base is 300, and we're multiplying it by 15%. And that's going to be equal to the amount. We don't know what that amount is. That's what we need to calculate. Okay, so I'm going to write amount here. And now to do this math, we need to convert this percentage into a decimal so that we can do the multiplication. In another video, link up here, I've shown how you can convert a percentage to a decimal, and recall that it's just moving that decimal point 2 spaces to the left. So this really looks like 300 times 0.15 equals the amount that we're interested in. Let's go ahead and write that down like this. 300. Now I've got 2 spots to the right of the decimal, so I'm going to hang on to that, and I'm going to write this problem as whole numbers. And what you can see is that because 300 ends in 2 zeros, I can do 15 times 3, which is 45. And then since there are 2 zeros that make this a 300, I'll put those zeros on the end. And then remembering that I had 2 digits to the right of the decimal. So if I put the decimal here, I have 2 digits to the right of the decimal. And that means that 300 times 0.15 is 45. So back to our diagram, this slice of the pie is 15%, but that's a percentage. What is the actual amount? It is 45, okay? So if this pie represented 300 M&Ms, then 15% would be 45 M&Ms. If this was $300, then 15% of $300 would be $45. If this was 300 monkeys, then 15% would be 45 monkeys. So the percentage doesn't change. A percentage is a fraction out of 100. 15% equals 15 out of 100. This is always true, but if I change the total value, the base, then the actual amount will be a different number, even for the same percentage. Let's look at a quick example of that. Watch how this problem changes if I do 500. Okay, I still have 15%, but my base, the whole thing, is now 500. And so if I go here and change this to 500, then this changes to 500. And the math down here changes to 500. 5 times 15 is 75, which means that now 75 is my amount. Okay? What happened here is the base changed, the percentage did not, and so 75 is 15% of 500, just like 45 in the previous problem 45 was the 15% of 300. Let's try another example that's a little bit different, but we can still use it. 37 is what percent of 185? Okay, well, let's go back and remember that the relationship for percentage problems is our base number multiplied by the percentage, okay? And that is equal to the amount. So what we're gonna do is we're gonna fill out the pieces that we know. The whole thing is 185. That's gonna be our base, okay? So 185 times the percentage we don't know. The word what means how much, what percent, we don't know. So let's go ahead and just pick a value, the letter R. R is gonna represent the percentage. And then that's gonna equal our amount. Well, we know what the amount is. We know, if I were to draw a picture here, the whole thing was the base. This is 185, the whole circle. And we've got a certain percentage, and we know that the number is 37, but what we don't know is the percent. What is the percentage that represents this piece of pie if the small piece has a value of 37, or the amount, but the whole thing, the base, is 185. So now we're gonna write 37 for the amount. For problems like this, where we're trying to calculate the percentage, we can do a little bit of algebra and rearrange this problem to look like this. The percentage is going to equal the amount divided by the base. Okay? What I'll do is I'm going to write that over here so you can see it with words. So now to solve, we simply do the division. 37 divided by 185. And you can do that with long division. You can put it in a calculator. But once you put that in, what you will get is a decimal 0.2, okay? And if you recall that to turn a decimal into a percentage, we move the decimal point 2 places to the right. That converts decimal into percentage. So this is 20%. That tells us that this sliver of the pie right here, this 37, is 20% of the whole thing. So we could rewrite this and say 37 is 20% of 185. Let's take a look at one final example. This is the third combination here. 27 is 30% of what number? In the first example, we knew the base and the percentage, and we needed to calculate the amount. In the previous example, we needed to calculate the percentage, but we knew the amount and we knew the base, okay? In this example, this third type, we know the amount and we know the percentage, and we need to calculate the base. All three of these equations are the same relationship. They're just written in a different form using some algebra so that you can pick the one that you need. In this example, 27 is 30% of what number? 27 is only a fraction. It's not the whole thing. Let's look at the diagram. 27 is equal to this 30% pie. So we don't know what the whole thing is. We do know that we have 30%, and we know that the value of that 30% sliver is 27. What we need to figure out is the base, the whole thing. So let's go ahead and use this third variation. It's all the same relationship written in a different form, but what we want to do is use this one because we know the amount and the percentage, and we want to calculate the base, okay? So our base, what we're trying to figure out, is going to be equal to the amount, which we know is 27, divided by the percentage. Now I'm going to write it as 30% so that you can see how these correspond to each other. But once we get into actual numbers, what we want to do is convert that 30% into a decimal. So this is going to look like 27 divided by 0.30. In a percentage, move the decimal 2 spots to the left, and that gives you the decimal equivalent. If you take a calculator and you type in 27 divided by 0.3, you will get a base of 90. 90 is the value of the whole thing. Okay, so what we've done today is we've taken a look at the relationship between a base, which is the whole thing, the whole piece of pie, the percentage, which is a sliver, and then the amount, which is the numerical value of that sliver. And we've said there's a couple different ways that we can write this. All three of these formulas are the same relationship between these elements. They're just written in a different form. And so you might be sitting there saying, well, Ron, that's great, but how do I know which one of these to use? Okay, and here's how you pick. Notice how in each of these three forms of the relationship of the equation, they all have something different on the equal side. For example, in this first one, amount is by itself on one side of the equal sign. And you would use this equation if you knew these two things, okay? Let's say that you're doing a problem and you don't know the percentage. That's the thing that's by itself, but you do know the amount and the base, okay? Then that's the one that you would use. In this third example, we knew the amount and we knew the percentage. These are the things that we know, and they're together on the same side of the equation. The thing that we don't know that we're trying to solve for is by itself on the other side of the equation. So when you're doing these percentages, start with a picture. If you're a person that thinks visually, start with a picture so that you can see what's going on. And then go back to this relationship and remember that this is always true, but we can use a little algebra to write it in a different form. And the form that you pick has the two things that you do know on the same side of the equal sign, and it has the one thing that you don't know by itself on the other side of the equal sign. And then you can put the numbers in and solve the problem. So I hope you saw in today's video how we can use that relationship between the base, the percent, and the amount to do any kind of a percentage problem. Send me any comments, tell me what you want to see next, and thanks for watching.